Hello, everyone, and welcome to the Heritage Foundation's Lewis Lehrman Auditorium. I'm Andrew Parks, the Associate Director of Lectures and Seminars. Thank you for joining us today. I just wanted to take the opportunity to remind everyone to please silence their cell phones and encourage anyone who's watching online to submit questions by emailing speaker@heritage.org. Hosting today's program is Melanie Israel. She is the Research Associate in the DeVos Center for Religion and Civil Society here at the Heritage Foundation. Melanie?
All right, well, thank you all so much for being here today. I know that this is going to be a very helpful, timely, and beneficial discussion. I want to introduce both of our panelists who we're fortunate to have with us today from the Charlotte Lozier Institute, which is the research arm of the Susan B. Anthony List. To my left, we have Dr. David Prentice. He's the Vice President and Research Director for the Charlotte Lozier Institute. He's an adjunct professor of molecular genetics at the John Paul II Institute, the Catholic University of America, and an advisory board member for the Midwest Stem Cell Therapy Center, which is a unique, comprehensive stem cell center in Kansas that he was instrumental in creating. Dr. Prentice received his PhD in biochemistry at the University of Kansas. Previously, he served over 10 years as a senior fellow for life sciences at the Family Research Council. And prior to that, he spent almost 2 decades as a professor of life sciences at Indiana State University and adjunct professor of medical and molecular genetics at the Indiana University School of Medicine. Dr. Prentice has taught numerous courses ranging from non-majors in biology to advanced and graduate courses, including developmental biology, embryology, cell and tissue culture, history of biology, science and politics, medical genetics, and medical biochemistry. And on his left, we're fortunate to have Dr. Tara Sander-Lee. She's a scientist with almost 2 decades in academic and clinical medicine. Dr. Sander-Lee received a PhD in biochemistry from the Medical College of Wisconsin. She then completed her research fellowship, training at Harvard Medical School and Boston Children's Hospital. After that, she became a faculty member at a research institution and established and directs her own clinical lab. Under her direction, new genetic testing was developed and offered to children suffering from things like 22q deletion syndrome, hearing loss, blood disorders, and epilepsy. Dr. Sander-Lee has served as a molecular pathology inspector and scientific consultant for various biotech hospital and academic entities. I say all of this to really drive home the point that these scientists know what they're talking about. So I want to set the stage a bit on why we have arrived at this moment with this current controversy surrounding fetal tissue research. And the current controversy can really be traced back to the most recent law we have on the books about pricing and payments for procuring fetal tissue, the NIH Revitalization Act of 1993. So this was a bipartisan law that was meant to address the controversy at the time surrounding fetal tissue research. And I say it had bipartisan support because the law was explicitly premised on the idea that there were safeguards that would prevent the commodification and commercialization of human fetuses. And unfortunately, despite the clear legislative history of the act, the executive branch across multiple agencies has failed to enforce the law's purported safeguards. In the years that the government has funded research covered by the law, HHS has never conducted an audit, and DOJ has only initiated 2 investigations in the last 2 decades, both of those after a bipartisan congressional request to do so. So in the absence of enforcement, companies engaged in transferring fetal tissue have essentially been operating under their own rules as they go along. Since 2010, 3 companies have paid Planned Parenthood affiliates to acquire aborted fetuses and subsequently sold the tissue to their respective customers at a substantially higher price than their documented costs. And Planned Parenthood has policies in place to have affiliates comply with the law, but affiliates didn't follow those policies. when Planned Parenthood learned that they weren't following these policies in 2011, it curtailed its oversight of the affiliates participating in the program rather than exercise oversight to ensure that their affiliates would comply. So that's the status quo that we're working with. And clearly, as multiple congressional investigations have shown, there's a lot that Congress and the administration need to do to change course. And so I hope that today we can really step back and discuss not just enforcement of current laws, but why is this research being done in the first place? Are there alternatives that would be more ethical, more successful? And so that's the discussion that I'm really excited we're going to be able to have today. And so we've got the experts right here. I want to turn it over to y'all to help explain what is this research, what are the alternatives?
Thank you, Melanie. And thank you to the Heritage Foundation for sponsoring this discussion. I want to start by going through a bit of that, why is this research being done, and look at a bit of the history in terms of the claims that have been made regarding fetal tissue research and its success or lack thereof. And they tend to fall into four groups, as you can see: transplantation, vaccines, humanized mice to study various types of infectious diseases, and basic science and developmental observations. Just to give us a little context, here is human development in the early stages, starting from Carnegie Stage 1A, where we all started, up through later stages of development to about 8 weeks. And so this is actually the embryonic stage of development, right before we get to fetal stage. The source of various human fetal tissues and cells that are under discussion right now have to do with these early and later stages of development. And from the moment of that Carnegie Stage 1A, when the sperm and egg meet, you have a unique and complete genetic code for a human being, a member of the species Homo sapiens, who will undergo self-directed development. To get embryonic stem cells, you have to destroy a very early stage embryo, usually about 5 to 7 days. To get the fetal tissue that's under discussion and fetal stem cells, death of the fetus at a later stage, usually after that 8 weeks that I showed you before, very often all the way up to 24 or even 28 weeks. Now, I want to take a little side path for a moment and talk about cell and tissue culture. And the reason is some of the activity that's undergone in terms of getting embryonic and fetal cells has to do with getting cells and cell lines. Why would somebody want cells? Well, if you grow cells in culture, and the first cell and tissue culture was actually done in 1907, you can control the environment, the physicochemical, the physiological, and the biological. You can characterize and get a homogeneous culture of cells, so you know you're always working with the same type of cell, rather than a mixed group of cells as you would find in any tissue that you take out of the body. You can fully characterize it. There's an economy and ease of handling to be able to work with cells in culture, and a homogeneous culture in particular, versus whole animals or whole tissues, which is the point of the current debate. There are some limitations that takes a certain amount of expertise to be able to grow cells in culture and keep those cells from becoming contaminated with various viruses, bacteria, and fungi. You can't get a lot of cells in many cases compared to a chunk of tissue, and they tend to be unstable after a while. But to start a cell culture, you usually start with that chunk of tissue. It's placed into culture, as you can see in the micrograph, and after a while the cells will grow out from that explant. As soon as that happens, you no longer have a tissue. You have a cell line. And it brings up a distinction I think has not been very clear in terms of the current debate. Under debate currently is the use of fetal tissue. But we're not talking about these historic fetal cell lines. Fetal tissue, especially in terms of what's currently under debate, is obtained from ongoing abortion, so that you always are getting more and more tissue from the source. Tissue transplants have been tried, and we'll go into that in more detail in a minute, with fetal tissue, although there are currently none of these going on in the US. The humanized mice use these sources of fetal tissue to study immunity and virus infection, various developmental studies, and they also serve as a source for some fetal stem cells. The fetal cell lines, however, in other words, you've started that culture of cells in the dish, it continues to grow and divide for years, for decades. The current cell lines used most originated in the 1960s and 1970s. Most importantly, there's no ongoing abortion. Now, the cell lines that we're referring to did originally start from fetal tissue obtained from an abortion. So there's an ethical taint for that particular cell. But it's not an ongoing type of act. The cells are propagated in culture. Often they're frozen so that then they can be thawed and grown later. They have been used for some vaccine production, for some basic research, and from genetic research. But again, there's a big distinction between the fetal tissue from ongoing abortion, which is the source of the current debate, versus these cell lines, historic cell lines. But you still see claims that fetal tissue, for example, was used to produce the polio vaccine. In point of fact, fresh aborted fetal tissue has never been used for vaccine production. The cell lines have been used, but not fresh aborted fetal tissue, even historically. In terms of transplantation, the first recorded instance I could find of any fetal tissue transplantation occurred in the UK in 1921, Italy in 1939, in 1928, and the US in 1939. All of these failed. They were attempts to transplant fetal tissue to alleviate some particular disease condition. There have been attempts to treat diabetes, anemia. All of these attempts to transplant the fetal tissue failed. More recently, patients were treated with fetal tissue in the brain to try and treat especially Parkinson's. One report noted that there was formation of what they called non-brain tissues within the brain of the patient. The biggest controlled studies that were placebo-controlled occurred and were reported on in 2001 and 2003. NIH-funded studies. They were attempting to treat Parkinson's with implanted fetal brain tissue. The 2001 report was featured on the front page of the New York Times, where the scientists themselves characterized the patients who were transplanted with fetal tissue as writhing, twisting, jerking with uncontrollable movements. And they themselves, the doctors, called these results absolutely devastating, tragic, catastrophic, and a real nightmare. The report that came out in 2003 again showed disastrous results for the patients. Over half the patients developing disabling tremors, much worse than the Parkinson's tremors they'd experienced, the dyskinesia. In 2009, there was a report of a Huntington patient transplanted with fetal tissue into the brain that experienced what the paper euphemistically called graft overgrowth. In other words, the cells were growing uncontrollably within the brain of the patient. In point of fact, NIH has not funded any clinical trials for fetal tissue transplantation since 2007. There have been attempts to transplant fetal stem cells derived from that fetal tissue, including some from ongoing abortion. But these have also not turned out very well. And there are recent reports of these fetal stem cells causing tumors. There was a company that attempted to transplant fetal stem cells obtained from a company called Advanced Bioscience Resources. And those clinical trials failed, were halted, and actually the company is shut down. So the whole area of transplantation of fetal stem cells and fetal tissue in general has not been a positive result. What about vaccines? Well, to grow viruses, viruses are obligate intracellular parasites. They have to grow inside a cell. They take over the replication machinery inside the cell and convince it to make more viruses rather than more cell components. So that's why you need living cells to grow viruses, and the viruses then used to create a vaccine. Culture and growth of viruses have been done in the past with whole organisms, in embryonated eggs, and also in cell and tissue culture, but cell culture in particular. And this is where those historic fetal cell lines came in. Again, these claims that fetal tissue has proved its value in a wide range of life-saving vaccines against diseases that include measles, mumps, rubella, chickenpox, polio, hepatitis A and B, rabies, and shingles. This was a quote made by Congresswoman Schakowsky in a hearing in 2016. It was reported in the Chronicle of Higher Education, and we noticed there had been an inclusion of several other supposed diseases in which fetal tissue or fetal cell lines in particular have been used to create the vaccine. When they were called on it, the author, Paul Baskin, actually called up the American Society for Cell Biology to ask, because Congresswoman Schakowsky had gotten this quote from the ASCB, it turned out they had not really done their fact-checking in terms of the real science in creating these vaccines. They had claimed that initially diphtheria, tetanus, and whooping cough vaccines had been created in these fetal cell lines, which was simply not true. They actually had to retract part of that statement. But again, this still wasn't even done in whole, fresh fetal tissue. This was done in fetal cell lines. The growth of poliovirus in fetal tissue was done as a proof of principle experiment by Enders and colleagues in 1936 and again in 1949. But they didn't grow enough virus to make any kind of a vaccine, and they weren't involved in using fetal tissue to create any type of vaccine. In point of fact, the original Salk and Sabin vaccines used monkey tissue. They didn't even use human tissue, let alone a human cell line. Later on, yes, those historic fetal cell lines, in particular WI38 and MRC5, were developed, first by Havlik in 1961 and then Jacobs in 1970. But again, these are cell lines. These are not fetal tissue. It's simply erroneous to say that fetal tissue has been used to create polio vaccine. Current polio vaccines, in fact, most use a monkey cell line. They don't even use human cell lines. And modern vaccines, including the newest successful Ebola vaccine, have been created without any fetal cell line, and certainly no fetal tissue cell line. This is a copy of the paper that Havlik published in 1961, where he first developed that historic fetal cell line and used it to show that he could grow poliovirus. But again, it's not fresh aborted fetal tissue. The point of debate we're at right now is not about these historic cell lines. It's about that ongoing abortion, fresh aborted fetal tissue, and, in particular, the use of federal taxpayer dollars to support that basic research. This just shows the WI38 cell line. You can see these cells all scattered around. There's no tissue there. Cell lines have been used for vaccines, but not fetal tissue. If I were to say something like human cervical carcinoma tissue has been used to make polio vaccine, people would probably think that very odd. What I'm talking about is the HeLa cell line, which also was used historically to grow poliovirus for vaccines. Nobody would consider that a fetal tissue or a human tissue. So we need to make sure we're very clear on what is actually under debate here. Here was another quote that actually had been published by the American Society for Cell Biology until the recent debate started up. According to the CDC, some vaccines, such as rubella and varicella, were made from the human cell line cultures, those historic cell lines I've been talking about. And some of these did originate from aborted fetal tissue from legal abortions in the 60s. but no new fetal tissue is needed to produce cell lines to make vaccines, now or in the future. Interestingly enough, the American Society for Cell Biology took down that little note once the current debate started in 2015, and when they replaced it with an updated little primer, they left out this little quote about not needing fresh fetal tissue. Point of fact, vaccines do not require fetal tissue. They could be manufactured using bacteria, yeast, animal cells, human adult cells. There are only economic and historic reasons that prevent this, but not scientific reasons. Here's just a little diagram of this new Ebola vaccine, again, not using any human cell lines, and certainly no human fetal tissues. One of the other claims that humanized mice are needed, and fetal tissue needed to create them for study of immune and infectious diseases. There are several alternatives. I'm going to leave to my colleague, Dr. Sandra Lee, to discuss this in more detail. You might remember in some of David Daleiden's videos, there was a lot of discussion about needing fetal liver, and in particular for some of these humanized mice. Why would they need fetal liver? Well, it turns out at that point in your life, while still in the womb, the liver is where your hematopoietic stem cells are. And so it's another source, very similar though, to bone marrow, in which to get that same type of cell that you can get from adult bone marrow or from umbilical cord blood. Basic biology research, there are alternatives, in particular things called organoids. But again, I'll leave this for Dr. Sandra Lee to give you more detail on. And just a look back at part of the development up to the point where you start to become a fetus, and then some other individuals, and these are the target dates at which much of that aborted fetal tissue comes from.
Thank you, David, and thank you for this opportunity to speak with you today. So I'm going to shift focus a little bit, and I will be talking to you about all of the many alternatives that exist that we can use in ethical alternatives instead of using these aborted fetal tissues. I just want to explain a little bit, why do researchers feel so determined that they need to obtain this tissue now? Why do they need this fetal tissue? I'm going to give you just a few examples recently from the literature. A lot of the researchers, they claim that they need fresh fetal tissue to study Zika virus. So what they want to do is obtain fresh aborted tissue between 9 and 13 weeks gestation in order to study viral infection. Another example is that they believe that they need aborted fetal tissue from 18 to 22 weeks in order to look at respiratory distress syndrome in infants, and specifically they want the lungs from the aborted fetuses. They also want to obtain the brains from aborted fetal tissue more in the earlier gestation, between 6 and 10 weeks. And they want to take that brain tissue and they want to dissect it, and they want to then implant and transplant the cells then directly into Parkinson patients. And in some cases, they need three baby brains from in order to do each transplant. In another example, they go specifically after fetuses that they know have Down syndrome so that they can study Down syndrome. And in a lot of cases, they actually are using it more as a control in order to validate their own model system that might have nothing to actually do with fetal tissue. Another main reason that they claim that they need these tissues is to look at infection. As my colleague, Dr. Prentice, mentioned, they're very interested in creating these humanized mice to be able to look at infections such as HIV and tuberculosis. So what are humanized mice? Well, as shown here in this picture, what they specifically do is that they want the thymus and the liver from the aborted fetus so that they can inject and implant that tissue or cell line directly into the mouse. And so that then that mouse will actually have an immune system that is similar to a human so that they can specifically study human infection. There are arguments regarding the use of fetal tissue for humanized mice, both for and against. For, many claim that it is better. They have better human T-cell generation using this model. They feel that there's improved engraftment, specifically if you want to use fetal bone fragments to study multiple myeloma. They also believe that there's improved engraftment of human stem cells using fetal liver. There are arguments, very strong arguments against, in that there are ethical sources that are immediately available now to use and are actually proving far better response in creating these humanized mice. And there's also humanized mouse models have been developed by researchers using genetic engineering, again, without the use of the human fetal tissue. Here's just one example of a report that was published in Stem Cell Reports where they are showing that a humanized mouse model can be generated using surplus neonatal tissue. So what this is discarded tissue from a surgical procedure that a normal part of the procedure, specifically when a neonate is going in to have a congenital heart, surgery for a heart-related issue, that they can actually remove the thymus and they can use that for subsequent experiments to generate humanized mice. So as you know, that this controversy has gained a lot of recent attention because it was determined that the FDA was contracting with a company that sold fetal tissue for taxpayer-funded research. As a result, the Trump administration canceled the FDA fetal tissue contract, and there is now the HHS has now halted again the FDA fetal tissue contract and plans to conduct a sweeping review of this investigation. So where were they planning to get the fetal tissue? Well, as mentioned earlier, from Advanced Bioscience Resources, which is one of the companies that procure the fetal tissue from the clinics. But what's interesting is that, as many of us know from the undercover videos from the Center for Medical Progress, is that ABR has been referred to the DOJ for profiteering. So this is just an example of what ABR has been doing when they receive a fetus from an abortion clinic. So what they do is they will obtain, for example, this was back in June of 2014, they obtained a 20-week-old fetus. They paid the clinic $60 for this one fetus. They then sold the different tissues, the brain, the eyes, the liver, the thymus, the lung, to 5 different researchers. They then, out of those transactions, they charged and they received over $2,000 total for those tissues that they sold. And so they considered that a service fee. But in addition to that, they also charged additional charges for shipping, disease screening, and also freezing. So it's not just that there was much more money that was transferred in addition to just that service fee that they claim. Which I'm showing you here is an actual invoice, a tissue acquisition invoice in which they sold 2 eyes, fetal eyes, for $650. So the real question is this a service fee or was there profit being made? And so I know it's difficult to maybe see these numbers, but what I'm showing you is that they determined prices that they wanted to charge depending on how old the fetus was. So if the fetus was in the 2nd trimester, they would charge like $200 back in 2010. But then in 2015, they upped that to $340. Whereas for a 1st trimester fetus, they were charging $420 in 2010, but then that increased to $550 in 2015. If this is truly just simple service fee, why did those numbers increase over the years? I'm also showing you numbers in which the 2015 fetal sales to the top 5 customers for what they made over $60,000 for selling these tissues, and that averages approximately over $400 per fetal tissue. But what's interesting is that then again, I just want to remind you that they only paid $60 for one fetus. So then they were making then on top of that well over $400 on average for every part that they sold. So why are people so interested in obtaining these tissues when there are so many ethical alternatives? And that's what I want to talk to you about today. So it is absolutely clear that the human body is amazing and has a lot of tissues and organs that are available right now from both adult and pediatric population that can be donated and discarded, and they can come from living individuals as well as even postmortem. And I'm going to talk to you about each of these, some examples. So when we look even just in the process of pregnancy, when a woman goes in and delivers a baby, just the pregnancy itself, the placenta, the umbilical cord, the umbilical blood, and the amniotic fluid are all precious resources that are normally discarded, but now researchers are understanding that these contain valuable stem cells that can be used for research and are being used to treat patients now and save their lives. And I want to tell you about that right now. I knew this from my own research. I knew that discarded tissue was incredibly valuable because what we would do is we would obtain discarded surgical tissue from kids that were going in for surgeries to address their congenital heart disease. And we could then take this discarded valve tissue and we could process it in the lab and actually establish a primary cell line that led to some very important discoveries and publications, as shown here in the Journal of Biological Chemistry, where we showed, where we were able to identify key mechanisms involved in human pulmonary valve development. What's really interesting is that you can also, just from skin, an individual can donate just a small little biopsy of skin, and from that, you can program the cells from that skin to actually go back and become more like an embryonic-like phenotype. So you can take these cells, you can grow them, as David showed earlier, how they're grown in a dish. If you give those cells the right media, the right proteins, the right signals, you will be able to work with these cells, and they will actually imitate and resemble embryonic stem cells back to that embryo phenotype. So this is also a very powerful cell line, induced pluripotent stem cells that can be used to study disease, and they're actually even looking at using these cell lines to actually correct, if we know of a specific ailment, they can actually correct these cells and actually look at treating individuals after they correct those cells. So you can actually then take these iPS cells, these, again, induced pluripotent stem cells, and what's really powerful is that you can then program them even further to actually generate a three-dimensional type organ, which David referred to as an organoid. And so what they've been able to show in the laboratory is that they can actually generate these organoids that recapitulate and resemble brain, lung, kidney, and liver. As shown in this picture, you can see the very detailed three-dimensional structure on the lower bottom middle panel of this organoid and how you can actually look specifically at how infection impacts this organoid. So in this case, they're looking to see how the infection of Shigella can actually impact this organoid. We know, and specifically when we start looking at infection by Zika, we know that you can actually make these brain organoids, and you can actually look, this was a seminal paper that looked specifically at how you can actually look to see how you can look to see how the Zika virus actually inhibits the growth of this organoid and actually recreates microcephaly similar to what we see in Zika infection in these fetuses. We see here that the cerebral organoids actually model human brain development and microcephaly and we know that these three-dimensional organoids can recapitulate the development and disease even in the most complex human tissue. And not only in brain, but also in kidney. We can see that if we generate these organoids from iPS cells, that we can create multiple lineages and model human nephrogenesis. So in addition to these organoids, I've talked to you about how we can take this discarded tissue that is normally discarded from surgical procedures. We can also take donated tissue in order to generate these amazing model systems like organoids and iPS cells. But what's probably the best well-known example of an ethical alternative that is actually treating people right now are the adult stem cells that are actually in almost every organ in the adult body. And this is the only stem cell that is proven successful in treating well over 1.5 million patients worldwide. And these adult stem cells are used to treat numerous diseases and conditions, such as cancer, stroke, and spinal cord injury. Bone marrow transplant is probably the most well-known example of this, in which a donor, from the donor, you will isolate their bone marrow cells, and then you will reintroduce those and transplant them into a patient to replace their disease cells. Another very rich source of adult stem cells are the umbilical cord blood. And as I mentioned earlier, like the umbilical cord is a very rich source that is, and this is, you can either donate the blood, but you can also store it, and because it withstands long-term cryopreservation, there's actually a low risk of viral transmission, and there's easily donated and stored in like such places such as Be the Match. And there have been actually greater than 35,000 blood transplants worldwide. Here are some incredible success stories using adult stem cells. So I want to introduce you to Sonia, where she suffered a stroke and she had arm and leg paralysis, impaired speech. She was treated with adult stem cells at Stanford, and she had amazing physical improvements within hours of the transplant. I also want to introduce you to Laura, who had a spinal cord injury from a car accident. She was quadriplegic and had paralysis from the neck down. And she was treated with adult stem cells and had significant feeling and movement in her body and was actually able to go on and to have a baby. And so I highly encourage you to look at this website, Stem Cell Facts, because there are many amazing stories out there that these adult stem cells are being used today to treat and cure these patients. So stem cells are not only treating people after they're born, but they're actually, we know that stem cells are treating patients in the womb before they're born. So here I'm showing you an image in which earlier this year, there were reports out about how this little girl, Eliana, was treated in utero because it was determined that she had thalassemia, a blood disorder, and they were able to go in before she was born and treat her with a stem cell transplant in order to treat her condition. And what's amazing is that these stem cells can be a mother's gift to her own child. So they can actually isolate these stem cells from the mother's bone marrow. They can collect them, process them, and actually inject them back into the umbilical vein. And then they'll circulate through the child in order to then repair the disease or treat the disease. So what I want to point out is that this is an excellent example about how there are researchers out there that have been trying to use human fetal tissue in order to treat conditions such as this that I just showed you. But then in a consensus statement from the first International Conference for In Utero Stem Cell Transplantation, they strongly stated in this paper that the clinical strategy for this stem cell therapy in utero should involve transplantation of autologous or maternal-derived cells. That means that the cells from the own individual or from the mother are the best option. It's not fetal tissue. They also highly encourage that the value of alternative cells such as mesenchymal stromal cells, which are actually, you can identify some of those from you can get those from umbilical cord blood, and amniotic fluid-derived cells. As I mentioned earlier, amniotic fluid is a very rich source of stem cells, that these are important cell lines that should be under investigation for other congenital pathologies. Nowhere in there does it say anything about moving forward with use of fetal tissue from aborted fetuses. And in another example of stem cells that are being used to treat the baby in utero, we have what's called transamniotic stem cell therapy that is being looked at in using, again, stem cells from either the amniotic fluid or the placenta to actually do almost like a reverse amniocentesis, where instead of going back through the umbilical vein, you are now going directly into the amniotic fluid to treat this baby before they're born. And there's a whole nother field of tissue engineering that we can't forget about either. So these are future strategies for actually correcting congenital heart defects in these children. So what they are proposing that we do is that we can actually isolate stem cells from the baby even while they're in the womb, and can actually create those iPS cells that I talked to you about. Or at the time of birth, we can get stem cells from the umbilical cord. Or another option is that we could again get stem cells from the surgical leftovers. 3 amazing options from the child that then you can actually generate, tissue engineer a graft that could then, you could surgically go in and perform surgery on the child early on, and then that graft would grow with the child and then correct the congenital defect so that they, so this is an amazing technology that is on the horizon and being done. And I don't want to ignore also this whole other issue of postmortem tissue. So postmortem tissue, there's amazing opportunities in living individuals, but there are important discoveries that are being made, especially shown here in this article, where they showed that you could isolate stem cells 2 to 17 days after death, both in neonates all the way up to 95 years of age. They were able to get them from eye, brain, muscle, arteries, pancreatic islet, and they specifically state that this could become a valuable resource for therapeutic application and could eliminate the dependence on fetal or embryonic sources. So they understand the controversy and the need to get away from this tissue because there are better ones on the horizon that are more ethical. And let's not forget about fetal tissue from miscarriages as well. In this transplantation proceedings, what they had done is they had looked at 164 miscarriages and ectopic pregnancies. What they found that 22% they were able to actually identify fetal organs. Of those, 63% were considered grade 1 and grade 2 quality. And what that meant is they were actually able to get viable cells and tissues from the liver, the thymus, the spleen, the bone marrow, the pancreas, the brain, the spinal cord, the kidneys, the lungs, and the skin. So what this means is that we need to be we need to pay very close attention and look more closely at miscarriages and how they could potentially be used for investigators that claim that they still need fetal tissue in order to do their research, because miscarriages are a very ethical option. So just from this article, what they predicted or estimated that if there are about 750,000 miscarriages in the U.S. annually. So if you look at these percentages of the viable cells that they got that could be actually used for research, we're looking at over 100,000 miscarriages per year with grade A 1 and 2 quality tissue that could be used for research. Here's a more recent example of a publication that has actually did this. So what they were able to show is that they actually were able to obtain spontaneously aborted fetal tissue from 10, 12, and 14 weeks gestation. They then isolated these human midbrain neural progenitor cells, and what they were able to do is then they characterize them in grave detail. They showed that they contain key markers of development that they can use as a research model, and they actually even engrafted them into a rat and were able to show that they localized and behaved as they should. So as they state in this paper, the long-term cultivated midbrain-derived neural progenitor cells retain stemness, midbrain fate specificity, and floor plate markers, and they also reversed impaired motor function in rodents, survived well, and did not exhibit tumor formation. So these need to be given much more attention in the future. And I also just want to, because of time, I'm just going to kind of go quickly through these last few slides, but we can't forget that technology is moving so quickly, and that the advancements that are being made for these children in utero, so not only the advancements to actually cure these defects and treat them in utero, but we know now that the survivability of these infants, that they are surviving at a much earlier time. So we know that from this study in the New England Journal of Medicine from 2017, that the survival and neurodevelopmental outcomes among infants born at 22 to 24 weeks of gestation, as measured at 18 and 22 months corrected age, that this study showed that there was the rate of survival without neurodevelopmental impairment significantly increased between 2000 and 2011. That means that people like Micah, shown here, that are born at 22 weeks, can actually survive and live very healthy lives. So here's a picture of him on the left, born at 22 weeks, and now at 2 years old. And we also know that very early on, fetal surgery is advancing at such a great pace that now there is such hope for families and their patients in utero that you can go in early on and perform surgery to repair some of these defects so that these children can lead healthier lives. So with all these alternatives that I showed you, why is there still a desire to obtain aborted fetal tissue and resist change? I'm going to throw out just a couple of thoughts. I think researchers are reluctant to change if they are currently using fetal tissue for research, receiving funds, or have an ongoing clinical trial. And so I think they really perceive that switching could be costly and cause delays. I think there's also a fear of the unknown for future developments, and what does that mean if we all of a sudden can't use this tissue anymore? There really is a lot of trust and faith that needs to go in that using ethical sources is absolutely always the right decision. I think there's pressure to use them as a gold standard with other model systems. I think researchers really believe that this will help them show the way, like it did with vaccines. But what research has showed us is that we never needed those to begin with. I think there's a lot of pressure to get published and funded. I think a lot of times ideology justifies the abortion, that there's a lot of groupthink. And I think they just truly believe that they're following the current ethical code of conduct. And with that, I will turn it back over to my colleague.
Thanks, Tara. Well, I want to finish up very quickly going through some of the regulations that Melanie had mentioned. There isn't actually a great deal. These first two slides have to do with the whole fetus, and the main point here is that you can't do any type of experiment on a whole fetus that's slated for abortion that it exposes it to any greater risk than one that would be carried to term. And so this was put in a number of years ago in Congress. In terms of actual fetal tissue research, it was allowed very early on, but then President Reagan put in a moratorium in 1988 on terms of federal funding of research involving fetal tissue from induced abortion. And again, back to what's really under debate, it's fresh aborted fetal tissue, ongoing abortion, and federal funding of that particular research. In January of 1993, President Clinton, once he took office, issued a memorandum lifting that moratorium. Back in '88, there were some studies done, but there were a number of people that wrote, including Mr. Bopp here in particular, that said if this is allowed to continue, you basically create a demand for more abortions and more fetal tissue by doing the research. In 1993, as Melanie mentioned, this particular statute was passed by Congress involving research on transplantation of fetal tissue. And I want to highlight that for you. This is about transplantation. The legal statute is solely directed that the Secretary may conduct or support research on transplantation of human fetal tissue. It doesn't talk about basic research with fetal tissue, which have been all the various things that Dr. Sandra and Lee and I have been talking about so far, and all that is currently funded by NIH. There are no clinical trials with aborted fetal tissue being funded by NIH. There's a number of parts in terms of informed consent, of the donor, also in terms of other aspects of informed consent, full disclosure, and so on, informed consent of the researcher in terms of having a statement on record that they realize this is fetal tissue that they're going to be using. Informed consent of the woman, well, as we saw, that often is not fully informed consent. This is from part of a consent form from the Marmonti Planned Parenthood in terms of consent to donate that aborted fetal tissue. And notice this phrase that was used, the research using the blood from pregnant women and tissue that has been aborted has been used to treat and find a cure for such diseases as diabetes, Parkinson's, Alzheimer's, cancer, and AIDS. Now, I was surprised because I didn't think any of these diseases had been cured, but this was put out there in a way to maybe influence the woman who was getting ready to go through the abortion. It's certainly not full informed consent when you're trying to tell somebody that fetal tissue has been used to cure these particular conditions. Again, further in terms of this statute, and again, it's on transplantation. It's to be done in accord with applicable state law. There's several places this is mentioned in the statute in terms of applicable state law. You have to abide by the particular states, and I'll come back to this in a moment, and we'll look at some of the states and what some of their laws are. The prohibitions also in this second part of the statute, 289G2, Melanie referred before to the idea about valuable consideration. Dr. Sandra Lee was talking about the profit and so on. The idea being you're not supposed to be selling and profiting from this fetal tissue. Yet what we saw, here's a different company than Advanced Bioscience Research called STEM Express that was also purchasing fetuses and aborted tissues from abortion clinics, harvesting the tissue's stem cells and then reselling them. And I've put up the costs that they were charging for stem cells of a certain type, CD34 positive from fetal liver versus bone marrow. I know it's a little hard to see, but for a vial of 2 million cells from fetal liver, they were charging almost $2,000. Charging a little more if you're going to get it from adult bone marrow. For this type of stem cell, though, also from bone marrow, $24,000 for a vial of 5 million of these stem cells. There might be a little profit there if they were paying $60 per aborted fetus and then charging this amount to pass on those particular cells. The other thing in terms of valuable consideration that was mentioned, it doesn't include the reasonable payments for shipping, quality control, preservation, processing, and so on. But we've obviously seen, as Dr. Sandra Lee mentioned, that several of these companies, both from the Senate and the House investigative committees, were referred to DOJ for potentially profiting off of those sales. In terms of that applicable state law, it's actually a surprising number of states that have passed laws regarding aborted fetal tissue and whether it can even be used, let alone be paid for. Many states have, similar to the federal statute, parts of their laws regarding payments or valuable consideration. But here's a list of a number of states where, for example, in North Dakota, it's illegal to do experimentation or research with aborted fetal tissue. Illegal to sell or experiment upon in Oklahoma. Illegal for research in South Dakota. Kansas has a series of laws, including it's illegal to use fetal tissue for the Midwest Stem Cell Therapy Center. They're supposed to be using adult stem cells because they're supposed to be treating patients. There are some, like Tennessee, that only limit themselves in terms of transfer, shipping, and payments, but a number of other states. Now, some of these have been enjoined. For example, the Indiana statute, that it was illegal to acquire, receive, sell, or transfer fetal tissue. But the list kind of keeps going on and on in terms of a lot of states that have moved ahead to say this just isn't an area of research that our state should be participating in. In terms of that federal funding, and again, this is one of the focal points of the debate, not whether the research will be illegal, but whether it will be funded with our taxpayer money. NIH for fiscal year 2018 is estimated to spend $103 million on fetal tissue. Point again, this is on that aborted fetal tissue. This is not regarding the historic cell lines. If all of this funding went away tomorrow through an act of Congress or an executive order or any other sorts of action that might be taken to stop the funding, it wouldn't affect those historic cell lines or any research being done with them. But it would affect that research being done with aborted fetal tissue. And so in terms of future steps, we've listed a few things up here to sort of begin the discussion in terms of oversight, in terms of actions through HHS, Department of Justice, the GAO, changes in the statutes that Congress might make. There's a little rider that's been proposed by Congresswoman Martha Roby that would eliminate federal funding for aborted fetal tissue. There might be executive orders. There might simply be more transparency in terms of where this tissue comes from and how it's being used. But we want to thank you for your time and open up for questions. Thank you.
Great. Thank you. And we'll have time for just a couple questions. So if you could state your name, your affiliation, and please be brief so we can get through a couple questions here at the end. We've got microphones, so if you have a question, you can just raise your hand. Don't all raise your hands at once. See one over here.
Hi, this has been so fascinating. Thank you so much. My name's Charlotte Schuyler with the Heritage Foundation. And maybe I'm just a little bit too pro-life, and I assume most people in here are. But it seems like we get into the details and really get down into the weeds. But the fact that abortion is legal in so many places, in so many stages, that the use of the tissue just kind of naturally flows from that when we concede that argument. It's like, whatever you want to use it on, go ahead. It seems like we have to win that argument first, that, you know, you're desecrating a human body. And the donor is not the mother. The donor is the kid. It's the baby. And they didn't give consent. So, I mean, do doctors, like, think about that? Do they step back? Like, what's kind of the feeling in the community? What's the thought there, if anything?
I think the feeling, that's an excellent comment, excellent question. Thank you very much. And I think this is a really important point to be made, that every human being has, that there is a dignity there to their human life. And then I think how a lot of physicians or scientists that want to use that tissue, they really separate the two. They separate the act of abortion from the disposition of the fetal tissue, and that they really believe that, you know, if that tissue is now made available, that some good can maybe come out of that. But I think, like you said, we can't forget that we need to respect the dignity of all life, and we can't just use this tissue and have it be sold like car parts for research, because the child itself did not consent to have that done. They deserve life.
Al Milliken, AM Media. Is there anything more anyone can say about informed consent legally? Does this vary depending on where you are?
From what we know, it does vary somewhat, and it's supposed to be approved by a local IRB in terms of the wording of the forms, as well as approval of any potential research. The example I showed turned out to be fairly common at a number of clinics that David DeLyden and his colleague had looked at in terms of what sorts of forms they had. But there are variations that have been seen in terms of that. So, you know, it becomes a matter of when are you really getting complete informed consent, because a lot of this is being done simply based on the potential results that might come. And the exaggerated claims that come from that are based on they want the tissue, and they want the tissue at pretty much any cost. And so rather than putting out some rather dreary facts, you can perhaps accentuate your ability to get tissue by exaggerating some of the claims.
Hi, I'm Julie Anista. I'm the press secretary for Congressman Andy Harris. And I had a question. Have you observed or recognized a culture change of the past few decades in relation to obtaining fetal tissue for research? And if it exists, does it have a relation to Roe v. Wade? And then for a third part, how do you go about changing that culture, if it exists, in public opinion and in the prerogative of physicians?
From what we have looked at, there hasn't been a great deal of change, frankly, in decades in terms of this particular obtaining the tissue, using it for research. You know, in point of fact, this is antiquated research, as the title of our talk said. The modern cell lines, let alone the historic cell lines, have far surpassed any sort of experimental and certainly any clinical applications of the fetal tissue. Yet you still have people who are going back to the same well over and over again with these mixed cultures, mixed tissues of cells, and so on, genetic variability and so on, that frankly makes the science poor science, let alone the question about the ethics of this science. How to change people's mind is a good question. I think one of the things that we need to keep pointing at is that there are many alternatives to the use of fetal tissue in research and in clinical practice. Dr. Sanderly mentioned adult stem cells having already treated over 1.5 million people versus the kind of success you got, which is pretty much nil, with fetal tissue. I think keeping to point at those alternatives and the successes there are what finally does change people's hearts and minds.
Maybe one more question.
Hi, Sandhya Raman from CQ. I was wondering if, given that HHS is deciding whether they're going to stop defunding this, if there are any efforts that Charlotte Lozier is taking kind of to, I know that they're asking from input, HHS is from a lot of different organizations, if you guys are doing anything in particular to kind of guide them into stopping this practice.
Well, we've been trying to do things like these talks and briefings and putting out fact sheets and putting out press releases, but pointing at the science. And in point of fact, we're not necessarily calling for defunding. We're talking about redirecting those funds to good science, to ethically derived sources of cells and tissues, and trying to keep putting out that, like I mentioned, the very positive aspects of the alternatives, which are far and away more successful.
And there are examples of institutes already existing within the United States that will focus only on ethical alternatives, such as the Midwest Stem Cell Center in Kansas. They're making amazing progress in developing therapies and treatments using only ethical sources.
Great. Well, I know that we've probably barely scratched the surface with the science of all of this, and I appreciate y'all being able to really break things down, because I think I speak for everyone in the room. I don't have the same kind of scientific background that y'all have, and so it's so helpful to have your expertise here for this discussion today, and I hope this was very informative for everyone here, and thank you again for coming.